So here's what we'll cover today. So we'll get to know what a computer network is, advantages and disadvantages of a computer network, the types of computer network, why what is NAT and why we use Azure NAT gateway. So by this end, I hope you all know what a NAT gateway does and how Azure uses it to manage internet access securely and efficiently. So basically, what is networking? So think of networking like human communication. For now, right now, I'm sharing knowledge. I'm sharing my knowledge with you by using words, right? So our network is now language. So similarly, when two computers share data or one or more data, they do it through networking. So networking connection can be either made by wired, this one is wired through Ethernet cable, or wireless, which is known as Wi-Fi. So basic data flow, like from how the data goes, it from laptop it goes to switch, from switch it goes to router, then the internet, then the ISP provider will send the data to the receiver. We'll be going through about this in the upcoming slide. So, summary to summarize, so networking allows computers to communicate just like people do using a medium to send information from one to another. So we know there are various types of advantages in networking, like one internet connection for multiple devices, shared access to software and user accounts. We have central file storage. We can use also shared access to devices like printers and scanners. So networking makes sharing easy, centralized, and cost efficient. Even networking is so powerful, but still it has certain advantages. As we all know that if the network fails, the access to files and devices get lost. Large networks may experience slow performance, and it requires, of course, a technical expertise to manage this. So these are the types of network which are called as personal area network, PAN, local area network, LAN, wide area network, which is WAN. So first we'll get to know what a personal area network PAN is. So I would like to explain from this diagrammatical sketch. So this image shows like a laptop. You can see a laptop, a smartphone, a printer, a desktop. All are connected to a wireless router to each other. So these connections are usually made by Bluetooth or a short range Wi-Fi, typically over a range of 10 meters. So what's the purpose of this WAN is that the PAN is that PANs are created for personal use, allowing for individual to connect and control their own devices. For example, sharing internet from a mobile phone to laptop, you know that is hotspot, or connecting a Bluetooth printer or a wireless keyboard, or playing music through your wireless headphones. So examples of PANs are listed here, which is smartphones connected to your smartwatches connected to your mobile phones, wireless headphones paired to your laptop or mobile, wireless keyboards and mouse, and car entertainment systems connected via Bluetooth. So PAN helps you stay connected to your personal gadgets easily and wirelessly, whether you are at home or while you are traveling or you are in your office. So it basically works silently around you all the time. So the next type of network is called as an LAN, which is local area network. So this is the diagrammatic sketch of a LAN. So a LAN is used to connect devices within a small geographical area. So this is the area, this boundary. Usually limited to one building like a home, office, college, or school. So from this diagram, I would like to say this image shows like there are desktops, laptops, printers, all are connected to a network router. This one is a router. They are like these devices are typically connected using Ethernet cables. This black wire are called as Ethernet cables for high reliability, but Wi-Fi can also be used in some steps. So the purpose of this local area network is that LAN allows devices in the same area to share files. We can share files between this desktop and this laptop and access the same internet connection, work on shared software or services. So it improves communication, saves time, and reduces hardware cost inside a single location. So example of LAN is that home networks where you can connect phones, laptops, and smart TVs. Small business company with connected PCs, printed and shared devices. Schools and colleges with computer labs, admin systems, and connected classroom. So LAN is most commonly used in the type of network at our schools, colleges, and homes. So it's fast, secure, and cost effective for a local device to communicate. So the next one is very important, which is WAN, which is wide area network. So we can see a world map over here, right? So this world map showing multiple offices and laptops located across different continents like North America, Africa, Asia, and so on. So all are connected through lines. This lines are represent WAN connection. So definition of WAN is what is that? A wide area network connects devices and networks over a large, over a long distance, often across continents. You can see often across continents or countries. The internet is the biggest example of WAN. So in this example, in this diagram, the blue lines represent WAN connections like undersea fiber optic cables or satellite links. So what is undersea cable? I would like to show you in Chrome. Just a second. For general knowledge, undersea cables are called as submarine cables. So if you go on to the site, you can see a world map again. So all these color lines are submarine cables actually. So let me click a line. Let's say let me click this blue color. So if I click this blue color line, it's one of a submarine cable. So we can see the cable length which starts from France and ends to Malaysia, I think so. It has a 20,000 kilometer range. We can see the owners up to here. We can see the starting point from where to where it's passing and so on. So this is what a submarine cable maps look like. Like in my PPT, I showed you from across continents, right? So from here it goes to here. Suppose if I send a message from my place Chennai to my one of my friend in Malaysia, the data gets traveled by this. So let's see how a submarine cable looks like. So this is what exactly a submarine cable will be looking like. It's actually under sea. So that's the main thing. Like you can see, it's under the sea. So coming back to the topic. So these are used to carry data between two or more countries, as you can see. So laptops and buildings show users and offices in different parts of the world, right? So they are not on the same LAN, but they are still connected via this WAN. So this allows global communication like sending emails, videos, data sharing, and so on. For example, let's say a company with offices in India, with office in India, US, and Europe, can use WAN to connect them. Services like Google Drive, Microsoft Teams, and WhatsApp work through this WAN. So this is what a WAN is. So how are these Ethernet cables connected in a laptop? So it's connected to a hardware called as NIC, which is Network Interface Card. So interface card is a hardware component that allows a computer or a device to connect to a network. So it acts like a bridge between the device and the network, converting data into signals and vice versa. So NICs can be either wired Ethernet or wireless Wi-Fi, depending on how the devices connects to the internet. So every NIC will be having an unique address, which is called as MAC address. We are going to learn about MAC address on the upcoming slide also. So MAC address used to identify the device on the internet. So it's essential for enabling communication between devices in local networks, which is LAN and the internet. So in real life, networking NICs are found in the PCs, laptops, servers, and even printers for network communication. So the benefits of NIC are that it enables fast and secure data exchange with other network devices. So the next thing is Ethernet cable. So Ethernet cable are connected to this port, network interface card. So the data gets traveled. So you all know this as a LAN cable. Actually, this is an Ethernet cable. We call it like a LAN cable. So Ethernet cable is like a physical cable used to connect devices like PC to switches and routers in a wired network. That's the main thing. This is not wireless. This is a wired network. So it transmits data using electrical signals and providing high speed and stable connections. So commonly used network Ethernet cables are like they are differentiated into categories like Cat5e, Cat6, and Cat7. So depending on speed and distance needs. So it's ideal for reducing latency and packet loss compared to wireless connection. So Ethernet cables are used in homes, offices, data centers, and service rooms. So benefits are like it offers more reliable and faster data transfer than wireless, especially for streaming, gaming, or heavy file transfers. Usually, I use this LAN cable for my gaming setup because my online game shouldn't be disturbed. So I prefer this one. So the next one is called as Ethernet switch. You can see this box. This is called as a switch. In the previous slide also you saw a switch. So Ethernet cable is connected to the switch. You can see that. So an Ethernet switch is like a network device that connects multiple devices in a local area network, and it enables them to communicate. So it uses a MAC address to forward data only to the correct destination devices by improving the network efficiency. So switches reduce like unnecessary data traffic compared to the hubs, which broadcast to all the devices. So managed switches offer like advanced controls like VLANs and traffic monitoring. So it's commonly used in offices, homes, and data centers to expand wired networks. So the benefits are like it ensures faster and more secure connection between connected device in the same network. So the final one is called as a router. We all have seen this in our own, this box with four antennas. So we all call this as a Wi-Fi router. So that's the thing. So a router connects different networks together. So most commonly, it connects your local network to the internet. So it assigns IP addresses to the devices and routes data packets and from external networks. So routers have built-in firewall to protect your network from external threats. So they often come with wireless access points, which is Wi-Fi routers. You can see, and to connect both wired and wireless device. From this back, we can connect an Ethernet cable to our laptops or gaming device, anything. So routers enable internet sharing across multiple devices in either homes or offices. So they act as a gateway to the internet and manage all incoming and outgoing activities, which is secure and efficiently. So we learned what are the physical hardwares like. We learned what a switch is, router is. So basically, the data here flows from laptop or desktop, which is connected to Ethernet cable to the switch. So you can see a laptop and computer connected with the Ethernet cable to a device called a switch. The switch will help. The switch has like many connecting device in the house or office which can talk to each other or share data. The switch is then connected to the router. The router sends the best. The router decides the best path for your data to travel, and it sends the data to the internet. The internet via this ISP providers, the internet service providers, they will send the data to the receiver by using the IP address. So this is how a traditional networking works. Now I would like to go into how cloud networking works. So in cloud networking, there is no physical hardware setups like routers, switches, and so on. Here everything is virtual. So which is called as a virtual network. So first, what a virtual network is. So in Azure, a virtual network or VNet is the foundation of your cloud infrastructure. So it's like you're building your own private data in the center of the cloud, like in the cloud center. So the main thing is that it's isolated and secure. Like each VNet is isolated from other in a walled compound. Like no one can access it unless you allow. So we can produce custom IP ranges. Like we can decide our IP ranges. So we can also create subnet inside. Like you can break VNet into smaller blocks for better control. So it can connect all Azure resources inside this VNet, like a few of the Azure resources, like virtual machine in AWS. You call it as EC2 instance, I believe. All the resources can be connected inside this single virtual network, and it can connect on-premises network like using VPN or express route for hybrid control or setups. So let's say why we use so VNets give you let me take you the example. So VNet is like your gated community, and your address IP. The rooms are like the subnets. For example, let's say I'm having 65,000 devices in my office. Let's say 60,000. Take it as 60. So the better way to distribute your If I have 60,000 in a single network, we can't control and monitor them, right? So we can differentiate 60,000 into three rooms. Like I can put 20 over here, 20 over here, and the remaining 20 over here. So we can divide them into three parts. So it can be easy for me to monitor and control them. So that's the main logic under them. So to summarize, VNets give you a private, secure, and fully controlled environment in Azure, just like how you design your own building and layout and access control. Just a second. So the next one is like we are further dividing virtual network into two or more subnets. So subnets are like a room inside your virtual building. So you can use them to group similar resources like I showed you in the drawing before. So we can divide VNet into like two or more subnets and breaking them into smaller parts, and we can have different resources inside them. So it helps in segmentation, like you can separate web and application and databases servers to apply different rules. So we can it is easy for us to control and access, and it improves security and performance. So it's also used in multi-tier architecture, for example, front end in one subnet and back end in another. So VNet is an office floor, like for an example, let me see, tell you. So VNet is like an office floor, and subnets are like each departments in the uh, office. Like let's say this one is HR department, this one is finance, and this one is IT department. So subnet helps you to structure and secure our Azure environment. So just like separating different teams in a building. So the next one is called as a route table. This is similar like a router. So what a route table does is does is that it is help for navigation system for Azure network. It tells the where your traffic should go. Like it controls your traffic flow. That we can decide if traffic should go, to the internet or internal subnet or on premises. So each subnet can have its own route table. So we can have its own route table. The main thing about the route table is that it will help us the data to reach its destination in a private and secure way. So I would like to draw an example here about this virtual network. So let me use a new board. Let me draw. So this is my VNet. I'm further dividing my VNet into two or more subnets. Subnet A and subnet B. And in each subnet, I can have my own services. For example, let's say in subnet A, let me have a VM which is running applications, app VMs. Let's say in subnet B, I have a VM which is having my databases. Sorry. So on each subnet, I can have my separate route table. Route table. Let's keep it as A. Route table B. And I can tell my route table what access I can give. Like if from this route table, I can say I can give it. I can say this VM can have access to outside internet, and this should not get any access. Let's say this one has internet access, and this one has no internet access. Just a second. So I am breaking this down into a simple diagram for us to understand and clear. So it would be clear. So this box at the top is called as a virtual network, which is a VNet. So it's like your private office floor, as you can see. So I'm dividing this into a further subnets like subnet A and subnet B. So now you can see two subnets, subnet A and subnet B. So these are like departments in your office floor. So let's say your subnet A might host your like I said, web app virtual machine. Subnet B is hosting your database servers. So I can allow for each for subnet A we attach route table A. This table has a rule that all outbound traffic should go to the internet. Why? Because app servers often need to reach external APIs, right, to download updates or connect with the users. So I am allowing this internet. For route table B, we attach route table. For subnet B, we attach a route table B, and this one says no outbound internet accesses are allowed because this is a crucial because database servers should never talk to the internet directly, so it keeps them secure and isolated. uh, Imagine your office, the marketing team will be having for example this application VMs. They need to access outside world to run advertisement, so you let them use the main gate. But the finance team which is having the databases VMs deals with sensitive data, so they are not allowed to access the outside gate. So by using different route tables for each subnet, we control resources can access the internet and which stays internal. So this is the core security principle in the cloud networking, which gives only the access that's needed. So getting back into the topic. So we all know what is cloud networking and traditional networking and how it works, right? So let's say what is an IP address. So let's say for example, if I'm ordering a food through Swiggy, so how will Swiggy deliver me the food? He has to know my address, right? The same way goes to the networking. Suppose if you're sending data to your friend would be having a IP address. Like let's say it's is their house number. So the network makes sure that the data gets reached correctly and securely. So that's what an IP address is. So IP stands for Internet Protocol Number. So it's like a digital address for your device when it's connected to a network. So just like our home has an address, so people can send letters. Your computer or phone needs an IP address, so data can reach it correctly. There are mainly two types of IP addresses, that is public IP and private IP. So mostly we used to get confused by the features of IP and the types of IP. So these are not type of IP. So type of IP are actually public and private. So these are the features in IP. So we'll get to know what the features are. First, we are talking about static IP address. So it's a permanent IP address assigned to a device. So it does not change unless you manually reconfigure it. So it's best for hosting a website, game servers, remote access, which is remote desktop protocol (RDP) and CCTV. It has a DNS configuration. For example, let's say your company server has a static IP like so on. This is the IP address. So customer can always connect to it without the IP changing. So this is what the static IP is. It's permanent and it cannot be changed unless you want to change it. So next is a dynamic IP. So dynamic IP is like a temporary and assigned automatically by DHCP server, like your internet service provider or a router. So it changes periodically, like when you restart your router or reconnect to the network. Like you might know when you turn on the Wi-Fi and check the IP addresses, first time it will show a different IP, and then you turn off and again if you turn it on, it will show a different IP. So that is what is called as a dynamic IP address. So it's best for home internet users, normal web browsing, streaming video calls, saving cost since it's cheaper. So for example, at home, like I said, when I turn off your Wi-Fi on and off, your IP might change from this number. This is just an example to this. So that's what a dynamic IP is. So let's see the major difference between the private IP and public IP. So the private IP is used within your home or office network. It's only visible inside that private network. That is, no third party can access the private network. For example, your laptop, phone, and TV at home all get get this private IP from your Wi-Fi router. So public IP on the other hand is the IP address assigned by your internet service provider, that is ISP, that is visible on the internet. So when you access Google or YouTube, the public IP is what the website sees. So we know that what are public IP and private IP and what are IP addresses. So who assigned this IP and how is this IP is into this network. So someone has to owns it, right? So the people who are owning or taking care of this IP are called as ICANN, that is Internet Corporation for Assigned Names and Numbers. This IANA is working under this ICANN, and they are actually like they are the Internet Assigned Numbers Authority. So they are like the World Health Organization of the Internet world. So just like how the World Health Organization manages global health coordination, this IANA manages global IP coordination. So IANA doesn't assign IP addresses directly to the users or companies. Instead, they delegates a large number of IP blocks to 5 regional internet registers, that is RIRs. So we all know these regions like APNIC is like Asia Pacific, which our country India includes. ARIN is North America, RAPNCC is for Europe, and so on. So this is the hierarchy. So ICANN is the head office, and IANA is the distribution center. So APNIC is our region, and a retailer, Geo or anything, Airtel, BSNL, so on, they get the IP from this company and they are giving it to us. So that's the main thing. So our IP assigns to companies or ISPs. So large organizations like internet service providers, telecoms, cloud providers get block of IP address from this APNIC. This one. Since I'm talking about India, I'm taking the example of APNIC. Suppose if we are in North America, this ARIN will produce the IP address for us. So these are called the IP ranges, such as this one is called as Class A IP address, and the companies are known as like LIRS. That is local internet registers like Jio, Airtel, BSNL, Vodafone are the examples in India. So how do individuals get IP? Actually, we don't get IP directly from this one APNIC. Our retailers, which are Geo, BSNL, Airtel, when we buy plan from them, they will provide us a certain IP. So, like for example, let's say if I'm using Geo at home, Geo has received a block of IP address from this APNIC, that is the Asia Pacific region, and they assign a part of range to me depending upon my plan type of connection, like type of connection, let's say mobile or broadband or businesses, whether I need a public IP for hosting a server or just private IP for basic browsing. This network providers, that is Geo, which I'm using right now, Geo handles this via network address translation, that is NAT, which lets many customers share a single public IP using a private IP using their home or mobile network. So in an organization, the company may have a static public IP or a set of public IPs for servers, VPNs, and so on. So they use their private IP, for example, 10.0.0.0, and so on. And this NAT address translation to route to the public IP. So that's the thing. So these are the factors which affect the IPs for a company. So the first factor is the size of the organization. The second, they will be asking the purpose for the internet service providers, hosting providers, enterprise, so on. So these internet service providers and these companies have to justify this APNIC, why they need this number of IPs. So IPv4 is actually strictly limited, and there is also IPv6 which is coming up. Actually, we are using IPv4 right now, which has 32 bits, and IPv6 has 128 bits, I believe. Yeah. So our IP address is differentiated in India. So each IP address range is like logged in a public registry with information like organization name, location, purposes, and so on. To check your IP address, you can use this site. For example, let's say my IP is something like 40. For just example, I'm saying 40.0.0.1. So this number might say the organization name, the retail providers which I'm using. This number may decide the location, and this will decide your local area location. So every number, like your electricity EB card, it will have your area number first, and so on, right? Same like that, the IP is differentiated. So there are different classes in IP. So why they were created, we'll get to know. So when the internet was at the starting age, it has vastly different sizes like class A, class B, and class C. So class A is used for large university or government government when they need millions of IP addresses. Medium-sized company might need 1,000 IP, so they will be using this class B range. A small business or home might need a few hundred, so they will be using Class C. We'll be learning about this Class A, Class B, and Class C in detail now. So this one is Class A. So Class A, it has IP range from 1.0.0 to 126. It has a subnet mask of 255.0.0 by 8. It has octet range from 1 to 126. It can host 16 million plus amount of users, and they're used for very large networks. For example, this internet service providers, government use this type of Class A networks, and the private IP range is 10.0.0.0. And you can see Class B also here, Class C. I would like to help you on how to calculate this host over here. Let me go to whiteboard. For example, we'll take this class 192.68.1.0. Point 168.1.0. It has a subnet of 24. You can see the slash 24. I'm telling you how to calculate the number of IPs in a classes. So let's say in this class C, we have 24 subnets. To calculate that, we have to first put the subnet value, which is 24. So actually, total number of bits in an IPv4 is 32. So what we have to do is we have to calculate the remaining bits for the host. That is, as you can see, I said you there are 32 bits in total in IPv4. 32 minus this 24, which will give you 8. So IPs are calculated by using 2 power this remaining value. So let's say total IP, which is 2 power 2 power 2 power 8. Can someone tell me what's the value of 2 power 8? Laptop button is not working. So
256.
yeah, thank you.
56.
Yeah. So in this class, we'll be having 256 hosts. We can see 254. So two numbers are reserved by the ISP providers. That is the first and the last one. So I this. So that's how we calculate the number of hosts in class C, class B, class A. The first one you have to take the subnet value, which is for this we have to take the subnet value 16. The remaining bits for the host we have to calculate from the total number of hosts, which is 32 minus 16. It will give you a value. Then we have to power it by 2. So you'll get the number of hosts. That's it. That's how you calculate the number of hosts in a classes. And I didn't explain you about class D and class E. So class D and class E are like exempted. So it is basically reserved for a few people for like research purposes and so on. So this class D has no subnet mask, and the use case is like it's used for multicast one-to-many communication, example streaming. And this class E is used for experimental and reserved one. So it's not used publicly on the internet. Like it's blocked in most of the systems. So these are the different types of classes. So why were IP classes replaced? So classes wasted IPs, for example, like if a company needing 300 IPs, they have to take the full class B, which has 65,000. Even though I only want 300, I have to get this whole 65,000, which is class B, which might be a bit costly. So that's inefficient. So what we use now in recent tradition is that the CIDR notation. Like we further divide them into subnet like 24, 16, and 12. So that CDR is nothing but classless inter-domain routing. So it allows flexible subnetting. So you can define exactly how many IPs you need without being stuck in a fixed class, that is A, B, or C blocks. So I've been telling you about a MAC address, right? So MAC stands for Media Access Control. So this media access control, it's a permanent physical address assigned to your devices. device's network card, which is in the NIC, like your laptop's NIC or phone's Wi-Fi chip. So think of MAC address like the engine number of a vehicle, like it stays the same no matter where the car goes. Meanwhile, the IP address is like a toll booth ticket. It changes depending on where you connect. So this is what a MAC is. So the difference between MAC and IP addresses. So in IP address, it's logical address like network level. MAC is physical base address in the hardware level. So it changes with the network. It stays the same. So it's assigned by the ISP, that is internet service providers or the router, and this is assigned by the manufacturer of the network card. So the format is like this: IP we can know this is class C, and for the MAC this is the format. So to summarize that, IP address is like your device's temporary location on a network. It can change anytime. And MAC is like a device permanent identity. It won't change. It's like your fingerprint. So private IP stays within your home and offices, while public IP lets you connect to the outside world. Without these, devices cannot find or talk to each other. So that's the main thing. So since we know about the how networking works, we'll get to know about what a cloud networking is now. So this is a diagram of cloud networking. So cloud networking is means like using virtual infrastructure instead of physical switches, like I said, routers, cables, and so on. It helps to connect resources like virtual machines, storage, databases, and so on across the internet or internal cloud system. So it's like taking the same networking setup from your office, but building it in the Microsoft Azure or AWS or Google platform, Google Cloud platform. So from here, let's start with the user. So it starts with the user who tries to access Azure hosted resources like a virtual machine or storage. You can see here. So this request is filtered by this NSD group. So NSD is like a security group, just like a firewall in traditional networking. So VNet, like all resources like VMs, storage are inside the secure boundary. You can see this boundary. So think of it like your own private network in Azure, just like your own building in a gated society. So subnet, you can see these are the subnet. A box inside the box is subnet. So inside the VNet, we divide the space into smaller subnets like separate rooms for application databases and so on. This makes traffic easier to control, so the network can flow easily. So inbound traffic, we can allow inbound and outbound traffic in this subnet. So inbound traffic either from Azure or the internet enters through this NSD, this one, that ensures that only allow traffic based on the rules. It has certain rules, so upon that rules only it will allow the network to pass to the subnet. So each resource like VM gets a private IP and used to talk to other resources inside Azure. If it needs to talk to the internet, we use either public or more efficiently a NAT gateway. This one is a NAT gateway, which we'll be learning in the upcoming slide. So here comes the role, which is NAT. So NAT is actually like a gateway, let's say a watchman. So instead of giving a public IP to every VM, we attach a NAT gateway to subnet. So like let's say I'm attaching a subnet. This one is subnet. If I attach NAT gateway, only this subnet can be allowed to the outside world. That is the IP public access. So using NAT, we can allow private IP to translate to a public IP. So it takes a VM private IP and translate it to a shared public IP to communicate within the internet. This saves cost, increase security, and is much easier to manage because it's like only one-way entry. So it's easy to monitor this NAT. So all outbound traffic from the VMs passes through this NAT gateway and gets converted into the NAT gateway's public IP, and then it reaches the internet. So the response from the internet comes back to the along the same route, ensuring consistency, speed, and security. So we are coming to a NAT. So what a NAT is, the definition of NAT is like a NAT is defined as a network address translation. From the name itself is it's defined. So it's a method used in networking to like modify IP addresses information in packet headers like while they are in transit across a router or firewall. So it basically allows multiple devices in a private network to share a single public IP. That's the main thing. A number of same devices, like let's say a three laptop having a private IP, they all can have same public IP. So that what this NAT does. So why is a NAT used? So it will help us to conserve like public IP addresses by allowing private IPs to connect to the internet using one public IP. So it adds a security by hiding internal network structure. It enables internet connectivity for devices in private networks, and it's essential for a cloud environment where many resources need external access but are private in the subnets. So the types of NATs are like there are three types: static NAT, dynamic NAT, and PAT. Static NAT is like one-to-one mapping between a private IP to a private IP to a public IP. So it's used when a device is like a server needs to fix a public IP. So next one is a dynamic NAT. It uses a pool of public IP which is already available in the cloud. It uses a pool of public IPs to map with private IPs. So mapping changes dynamically based on availability. So the next one is PAT, which is port address translation. So it maps multiple private IPs to one public IP using different port numbers. So it maps multiple private IPs to like that. So most commonly used type for this, like it's ideal for a home or enterprises internet connection. So the same NAT, the difference between NAT and route table, we can see the purpose of NAT is that to translate private IP address to public address and so on. It can even translate public to private. That is, it allows outbound internet access. The route table will determine the path the packets need to reach the destination. So the main function is that it hides the internal network structure and enables internet access for the private IPs. It directs traffic between networks based on IP addresses. The operation does is that it translates like public to private, private to public, so on. It just gives the routes for the data to travel. The location in network, it's usually at the network edge like routers and firewalls. It is present in the routers, host, and layer 3 devices. So it's bidirectional translation. It's one-way decision making. That is only forwarding the packets. That is only forwarding the data. It can modify packets like yes, it can change IP addresses and so on. It cannot change. The common use of this NAT is that it allows internal device to access internet using one public IP, and here how traffic should be routed to various networks. So it is aware of both source and destination IP address. It's only primarily concerned with the destination IP address. So these are the differences. So we are coming into Azure NAT Gateway. So what is Azure NAT Gateway? So Azure NAT Gateway is like a fully managed service. It's a fully managed service which allows virtual machine in Azure to connect to the internet even if they don't have a public IP. That is, I can run my virtual machine in a private IP by using this NAT gateway. I will get a public IP and then I can get access to the outside internet. So where is it applied? We attach NAT gateway at the subnet level to not on the individual VMs. That means all the VMs in the subnet automatically gets the outbound internet access. That is that I don't need to attach the NAT gateway to each separate of this VM. This is a virtual network. Inside a virtual network, I am having a subnet. If I attach this NAT gateway in the subnet, I can get easily a public IP for all these three VMs. So that's the main concept. And what it does is that the NAT gateway translate each VM's private IP into a public IP. So that is what is called as network address translation. So why is it better than giving each VM a public IP? Is that instead of assigning public IP to every VM, which is costly and insecure, NAT gateway, like we know, gives the outbound access only to the main thing which we want. So we can decide like which VM we want to give. So why use Azure NAT gateway? We learned that. So these are the benefits of NAT gateway. It has simplified management like Azure NAT gateway, like what to say. Uh, Azure NAT gateway simplifies the management for outbound internet connectivity for virtual networks, eliminating the need for complex user-defined routes. It has provides high availability and fully managed solution, ensuring it has a constant outbound internet connectivity and so on. We also know it has a main advantage scalability. That is, we can scale up and down resources when depending on the traffic level. It has a static IP addresses. It has more security and is cost effective. So we'll now see a practical thing on how to start an NAT gateway. I'll get you into Azure portal now. Just a second. So this is how Azure portal will be looking like. So a brief introduction about Azure portal. Like this is the like a menu. It's just like a hotel menu card where you can see the food. Here you can see all the services in Azure. This is the search box. If you can type a service, it will appear over here. So we are, since we are learning about NAT gateway, I would like to create how NAT gateway works and so on. So first, to create a NAT gateway, we'll select NAT gateway. We need to type NAT gateway first. First, we have to create a NAT gateway. So these are the basic tabs. In this tab, we have to select the subscription. For me, I'm using the trial account for 30 days. So this one is my subscription. Then we have to select a resource group. Resource group is a logical container which will hold like all the services in your Azure. Let's say this is a resource group. Here, if I start a VM service, it can hold VM over here. If I start a storage account, it will get stored over here. So it's like basically a logical container where all the services are stored so that we can manage and modify them later. So we'll get in the NAT gateway first. So let's click create. We have to select the resource group. If you didn't create a resource group, we can create using a new like this one. Since I've already created, I'm going on with this. So I'll enter the NAT gateway name. I'll put NAT gateway. Then we have to select the region. Let it be East US for now. And the availability zone, no zone. And this TCP. This TCP is defined as this TCP is nothing but like it is having 4 minutes, right? So this TCP is like a what to say? This TCP is transmission control protocol. Like it's a communication protocol used by computers to send data reliably over the internet. So it ensures that your data reaches the correct destination without getting lost or corrupted. So what this TCP idle timeout in NAT gateway does is like, let's say if your VM stays idle, like if your VM no data is sent or received by the from this VM, this TCP will automatically close the NAT gateway. That is that your client cannot use this after 4 minutes. We can decide this time up to, I think so, 2 hours. Yeah, 2 hours. 60 plus 60 is 120. For now, I'll go with the default 4 minutes, and then we'll go to the next outbound IP. I'll create a new public IP addresses. Like IP. Then I'll click OK, and I'll click review and create. When the validation is passed, it will show a green signal over here. Then if you click create, NAT gateway is created. It will take some time to deploy. Yes, it's deployed. You can see. Now what we need to do is we have to create a virtual network so that this NAT gateway can sit on that. To create a virtual network, the same step on the search box, we have to type virtual network. You can see this one is a virtual network. Same process, click create. I'm selecting the same resource group. I'll put my virtual network name as, let's say, VNet1. And I'll select the same region of my NAT gateway. Then I will go to security. Since I am not using any public IP over here, it won't support RDP, as you all know. Since I'm using only private IP, so I need to enable this Azure Bastion, which allows my internet to access my virtual machine, which does not require any public IP. So that's the main thing. I will enable this, and I will name it as Bastion itself. Maybe we need to, and I will create a new one. Let's call it as public IP. We'll click on OK. Next, we'll go to IP addresses. On the IP address, we'll edit this one. We click on this pen thing, it's the edit one. I'll name it as subnet 1. We'll go on with the default IP address ranges and so on. And here I have to select my NAT gateway, which I have created previously. So my NAT gateway name is appearing over here. I'll click the NAT gateway and let's say save. So it's saved here. You can see my NAT gateway over here. Now we have to click review and create. It will take some time. Let's wait.
Bro, I have one doubt, Harish.
Tell me, bro.
Which one is more affordable, traditional networking or cloud networking, bro?
So you mean to ask which one is more cheaper? That is
Yes, bro. Yeah.
Oh, okay. Meanwhile, this is loading. I'll explain you that. 1 second, bro.
Okay, bro.
So we'll compare like traditional networking and cloud networking. Let's say this one is traditional networking. This one is cloud. So let's say the initial cost first. So the initial cost will differentiate for both the categories. Initial cost. So for initial cost, the traditional networking, as you know, we need to buy the routers, switches, cables, switch, servers, data centers, and so on. So it is like paying upfront, and it is very high. In cloud networking, it is low because you know that it is like a pay as you go model. So we only have to pay for what we use. And the initial cost. This one is the initial cost. The next one is that maintenance cost. We'll see maintenance. You know, cloud services will take care of the maintenance, so we need to do anything. It's like low to medium cost in cloud. Your maintenance cost might be a bit high because we pay for the power. We have to consider the cooling systems so that the hardware will function efficiently. We have to do some hardware upgrades and so on. And let's see, maintenance. Maintenance here it's high since we have to pay for power and so many things. Here it is low to medium because the providers like Azure or AWS, they themselves will handle the maintenance and upgrades. And scalability cost, as you can know, once when I set a data center completely, it's like scaling requires like buying new setup like hardwares and so on. It will be a very your scaling is easily we can affordable and it's instant upgrading since it's in the cloud. Expensive since we have to buy new hardwares. Scalability here is affordable and instant because the cloud server we can do it instantly. And disaster recovery, one of the major thing. So disaster recovery here in traditional networking is very costly because you need to back up the sites and infrastructure, right? So here it's costly. In cloud, we have built-in and affordable cloud office backup redundancy. So in general, like what to say, traditional networking is more expensive because you have to pay upfront and there's higher maintenance cost. While generally cloud networking, it's generally cheaper and flexible over time, bro. So cloud networking is actually cheap.
Okay, bro.
So actually, this deployment will take a bit time. So kindly bear with me. So usually it will take like more than 10 minutes for this bastion to apply. So that's the problem. So I wanted to show from the beginning how to create a NAT network gateway. So I am doing it from the first step. Once this bastion is completed, the other steps will take won't much time. Yeah, it's done. So sorry for the delay. Azure is like a bit slow today. I don't know why. So next, what we are going to do is we are going to apply this NAT gateway in the virtual machine. So what we have to do is on the search box, we have to type virtual machine. So you can see a computer like thing. So this one is called as virtual machine in Azure. I think so in AWS we call it as EC2 instance, right? Yeah. So here we have to click create. We have to select the virtual machine. The same process, we have to select the resource group. We have to put a name for a VM. For now, let me say I'll put VM1. I'll create in the East US region. For the availability option, I'm not going with any availability set. I'll go with the default one. So for the security type, I'll go with the standard one. So let me use this Linux server. Let it be this one default. Size, let it be this one. Since we don't have a public IP, I'm going out with this password thing through Bastion. So which will require my username and password. So let me say I'll type it as Calvin. So I'll select public inbound ports as none since we don't have any public IP. Then we'll go on to the networking tab. Virtual network. Since I've created a virtual network, it's automatically assigning that. I'll go with the network interface security as advanced. Uh, I'll create a new security group. Let it be NSG1. And these are how you can allow the outbound and inbound rules. For now, I'll leave it the rest like default itself. Click OK. And let's leave everything as default. Let's go with the review and create. So usually virtual machines in virtual network with a Bastion host, like I said, doesn't need a public IP address because this Bastion provides a public IP, and the VM uses private IPs to communicate within the network. So I can remove the public IP from the inside the VM itself. So the validation is passed now. I'll create. I'll click create, and once it's done, let's test this NAT gateway whether it's allowing my Linux to get access from the outbound network. So meanwhile, the VM is getting deployed. Let's check our public IP number. You have to type public IP address. So this one is the NAT IP which I have created, public IP. So kindly note this. If anyone can note this number, it would be nice. Or else, wait. Okay, I have noted down. So this is the IP, public IP. I hope the VM is created. It's created. Now we'll select the VM, which we will try to connect the VM now. So click on VM, click on connect. Since we don't have a public IP, we cannot connect it through RDP. So I'm using this Bastion method. So click on Bastion. I have to put my username, which I wrote Calvin. Then I'll put the password. Now I'll click connect. As you can see, I'm connected to my Linux server. I hope my screen is clear. I have connected to my Linux server without using a public IP. As you can see, we are using a private IP over here. Now let me try to connect to my public IP now. If I try to connect, this number should be visible now. So where is my VM? Here. 1 second. So you have to type the curl command, curl if config dot me, and click enter. Once when I try to enter, as you can see, I got my public IP through the help of NAT gateway in a secure manner. So I hope this is the number 172.191.90.44. Yeah. So that's how you check the uh, IP in your virtual machine. So I would like to explain this process, like what I did actually. So I'm creating a secure anyway, there's no public IP which is more secure. So outbound internet access is still possible through this NAT gateway. So I access the VM using this Azure Bastion where I don't require any type of RDP or public IP. So, for example, in this real world production, let's take, we don't need to expose this VM to the internet directly, right? Because what we use here is we use this Azure NAT gateway to allow outbound internet connection securely. This Azure Bastion, the method which I use, the method which I use now, it's used to connect the VM privately without a public IP. So, when the VM sends a traffic like curl this one, so it sends a traffic to the outside network. Like it goes out via NAT gateway, and the NAT gateway replaces the private IP of this VM with the public IP that in a static way. So the response came back to the VM through this NAT gateway. So even though VM has no public IP, I can still access the internet and download packages and updates and so on. So this is what a NAT gateway does. So I hope it's clear for you all. So to summarize, we have learned how networking works. We have learned the types of network. We have known the physical hardwares like NIC, switch, router, so on. We know what cloud networking is and what it does. The difference between cloud and traditional networking. We know what a NAT is. How Azure uses a NAT gateway to help us control the outbound traffic and so on. So thank you all, and I hope this session was clear for you all.